Hello and welcome to this lesson on custom views and Canvas in Android. In this lesson, we will cover the components of a custom view and the Canvas component used for drawing a view on the screen. A convenient way to create a custom view is to extend the view class and override or implement methods and properties accordingly. All of the view classes defined in the Android framework extend this view class. A custom view can also extend a view directly, or you can save time by extending one of the existing view subclasses, like a button or text view. To add a built-in view to a user interface in Android, it is customary to specify it in an XML element and control its appearance and behavior with element attributes. Well-written custom views can also be added and styled via XML. To enable this behavior in a custom view, it is required to define the custom attributes for a view in a declare styleable resource element, specify values for those attributes in the XML layout for your application, retrieve attribute values in runtime in your custom view, and then apply the retrieve attribute values to the custom view. Attributes are a powerful way of controlling the behavior and appearance of views, but they can only be read when the view is initialized. To provide dynamic behavior, you can expose property getters and setters for each custom attribute. The most important part of a custom view is its appearance. Custom drawing can be easy or complex, according to an application's needs. This lesson will cover some of those operations in explanation and in code. Drawing the UI is only one part of creating a custom view. You also need to make your view respond to user input in a way that closely resembles real-world actions. This is part of the material design overview in Android. For example, images should not immediately pop out of existence and reappear somewhere else, because objects in the real world don't do that. Instead, images should move from one place to another fluidly as they would in the real world. The most important step in drawing a custom view is to override the onDraw method. The parameter to onDraw is a canvas object that the view can use to draw itself. The canvas class defines methods for drawing text, lines, bitmaps, and many other graphics primitives. You can use these methods in onDraw to create your own custom user interface. The Android graphics framework divides drawing into two areas: what to draw, handled by the canvas class, and how to draw, handled by the paint class. The paint class holds the style and color information about how to draw geometries, texts, and bitmaps. For instance, Canvas provides a method to draw a line, while Paint provides methods to define that line's color or thickness. Canvas has a method to draw a rectangle, while Paint defines whether to fill that rectangle with a color or leave it empty. Simply put, Canvas defines shapes that you can draw on the screen, while Paint defines colors, styles, fonts, and so forth of each shape that you're drawing with your canvas. In order to properly draw your custom view, you need to know what size it is. Complex custom views often need to perform multiple layout calculations, depending on the size and shape of their area on the screen. You should never make assumptions about the size of your view on the screen. Even if only one app uses your view, that app needs to handle different screen sizes, multiple screen densities, and various aspect ratios in both portrait and landscape mode. In order to handle these changes, you will receive callbacks to layout events by the methods of onSizeChange or onMeasure in order to change the composition of your custom view for the surrounding area or changes in the layout. Like many other UI frameworks, Android supports an input event model. User actions are turned into events that trigger callbacks, and you can override the callbacks to customize how your application responds to the user. The most common input event in Android system is touch, which triggers the onTouch method. You can override the onTouch method to handle the user input events. The gesture detector is a class that detects various gestures and events using the supplied motion events class. The gesture detector onGestureListener callback will notify users when a particular motion event has occurred. This class should only be used with motion events, reported via touch events. In order to use the class, you simply need to create an instance of the gesture detector for your view. Then in the onTouch motion event method callback, ensure that you call onTouch motion event. The methods defined in your callback will execute when the events occur. The gesture detector instance will then receive an its onTouch event call, the motion event, and process it accordingly. The gesture detector class and listeners allow to detect gestures like on double tap when a double tap occurs, on fling when a fling event occurs, on long press when a long press event occurs, and on down when a tap occurs with the down motion event that triggered it. In addition, scrollers can be used to collect the data you need to produce a scrolling animation in response to a touch event. Implementing a custom scroller should only be necessary for special scenarios, for instance displaying a scrolling effect in response to touch gestures using scrollers. To speed up your view, eliminate unnecessary code from routines that are called frequently. Start by working on onDraw method, which will give you the biggest payback. In particular, you should eliminate allocations in onDraw, because allocations may lead to a garbage collection that would cause a stutter. Allocate objects during initialization or between animations. Never make an allocation while an animation is running. In addition to making the onDraw method leaner, you should also make sure it's called as infrequently as possible. Most calls to onDraw are the result of a call to invalidate, so eliminate unnecessary calls to invalidate. When possible, call the 4-parameter variant of invalidate, rather than the version that takes no parameters. The no-parameter variant invalidates the entire view, while the 4-parameter variant invalidates only a specified portion of the view. As of Android 3.0, the Android 2D graphics system can be accelerated by the GPU or graphics processing unit hardware found in most newer Android devices. GPU hardware acceleration can result in a tremendous performance increase for many applications, but it isn't the right choice for every application. The Android framework gives you the ability to finally control which parts of your application are or are not hardware accelerated. The Canvas class holds the draw calls. To draw something, you need 4 basic components: a bitmap to hold the pixels, a canvas to host the draw calls, a drawing primitive, like a rectangle, path, text, or bitmap, and a paint object to describe the colors and styles for drawing. The canvas comes with lots of convenience methods for allowing to easily draw items on the canvas itself. These methods can include draw arc, draw bitmap, draw color, draw line or lines, draw oval, draw point, draw rect, draw text, and many, many more to allow to easily draw the needed custom UI on an available canvas. Now let's take a look at how to implement a custom view in code in Android Studio. In this example project, you may notice that we have 2 modules: the app module, which in this case is the example application, and the custom view lib module, which will be a library project module. In this example, we will show how to create a custom view in your projects, which we have created in this library lib project. That way, we can use it and reuse it for different projects in the future. In order to start a library project module, we simply need to click the File menu, and then New Module. In the selecting what type of module we'll be developing, instead of selecting the phone and tablet application, which we normally select, we select the Android library, and then click Next. In the continuation of the guide, we'll be able to give our module a name, as well as other characteristics for this module. But let's go back to the module for a library project that we've already created. You'll notice that we have no activities for this module, because this will act as a library for the new custom view that we are creating, called the multi-state view. Now let's take a look at some of the properties for this custom view. First, let's look at the attrs.xml file for our attributes. In our attributes file, we see that we've declared attributes for the multi-state view. One attribute of the name numStates that is an integer or reference. In this sample, we will create a custom view that has a multi-stated view. This attribute will declare how many states the given instance of the multi-state view we should have. Declaring an attribute here will allow us to easily declare the number of states of a specific multi-state view in an XML layout which we can use in our activities. Now let's take a look at the Java code for our custom view. We can see that our custom view, the multi-state view, extends the view class. If, for instance, we wanted to make a multi-state button, we could easily extend a derivative of the view class like the button class to take advantage of their additional logic and methods. We have some constants for our view, like the default number of states. In this case, if none is given, we will make that 2 states. And a declaration of the max number of states, which in this case is the hexadecimal number FF. Now let's take a look at the constructors. We see we have several constructors declared for this multi-view class. Each of them call an init method and pass the attributes value they receive to that init method. So let's take a look at that now. In the init method, we try to obtain the attribute for the numStates value that we have seen previously in our attributes XML file. If the attribute was not declared or we are unable to obtain it, we will set the mNumStates member variable to the default value of 2. We then verify that the numStates value is less than the max number of states available, and if not, we set it to the max value. We then register this view for onClick events for the changing of the state. This can better be accomplished by overriding the onTouchEvent method in this view class and dealing with the appropriate touch events accordingly. But for this example, we will use the optimize onClick event logic. We then call a method setStateColor and we define the stateDiv member variable. The goal of this custom view is to have multiple states, and we will denote different states and changing states by changing the background color of the view. We will start with the white background and gradually increase the value of the red, green, and blue values in this color by the mStateDiv variable so that it will approach black for the last state and then recycle back to white. In our onClick method callback, we check if we have just passed the last state. If so, then we change it back to the 0 state. We then call the setStateColor method where we set the background by generating a color whose RGB is equal to the new state value. Now that we have created our custom multi-state view, let's take a look at how we can utilize it in our application. First, in order to use this library in our application, the application module will have to reference this library. If we right-click on our app module and open the module settings, and then go to the dependency tab, we can see a reference to this custom view library listed as a dependency. A dependency to a local module can easily be added by clicking the plus button we see here, and then selecting the module dependency, and picking the module that we'd like to have as dependency for this project. Let's take a look at the main layout for our example application, which is Activity Main XML. We see in our main activity UI, we have a relative layout with one child, which is the custom view which we have just created. Note that the full qualified name for the view, including the package name of the library module for the multi-state view, is listed here in the view node. We then add normal view attributes like layout width and layout height. Then we can see that we have the attribute which starts with custom, which is our new custom attribute which we have added. If we have a look at the declarations in our relative layout, we can see the declaration of xmlns:custom equals http schemas.android.com/apk/resauto, which will allow us to declare attributes not from the Android resource system. Using this qualifier, we can declare the custom attribute of numStates to be 3, so our view will have 3 states. So now let's take a look at the Java for our main activity. We can see in our main activity that we simply have our onCreate where we set the content for our main activity to the activity main XML. Nothing else is needed because the view itself will handle the logic and the event handling for changing states. So now let's run our application and see how it runs on the emulator. Because the background color of our main activity is off-white, we can easily see our white first state multi-state view. Now if we click on the view, it will change to gray for its second state. And if we click again, it will change to a darker gray. With one more click, and we return to our first state, since this is a 3-state version of the multi-state view. This view can be sized, added, and manipulated just as any other view like a text view or image view. Now let's go back to the XML for this activity and change the numState attribute to 5. Now when we run the application again, we see that our application looks the same, But when we click on the multi-state view now, we see that is now a 5-state multi-state view, as we have declared it in our activity main XML. Thank you for joining us in this lesson on custom views in Canvas and Android. Join us in our next lesson where we'll take a look at the camera and camera APIs in Android.